ठीक. Hello, welcome. Hello everyone, a very good evening. Is anyone there? Can you please confirm whether sound is coming or not? Hello everyone. Yes, very good evening to you. Is the sound clear? Am I audible? Am I clearly audible? Please let me know. Am I audible? Are you able to hear me? Yes? Very nice. So welcome everyone to the YouTube channel of AgriAddict, and today it is going to be the last video of most expected series. All right, enough question solving have been done. We have done 2 papers were done by me, 2 by Purvita and 2 by Rohit. So we have done 6 papers. 6 into 120 is equal to 720 questions. We have done the PYQ. So this is going to be the last session of the most expected series, and after this we will be starting with marathon. That marathon is going to be one of a kind. I would suggest all of you to please join the marathon. That will be a perfect revision for you for the last month with the upcoming GRF knocking at your door. All right, so without wasting much time, we will start. So it is, as you all know, this is a brief introduction about me. I have done my UG at GKVK, Masters at CRRI, and then I'm currently doing PhD in ICAR IRI, and I have got AIR 5 in JRF, AIR 9 in SRF. So let's begin. All right. So this is the first question of today, and it is a very easy question. It is one of my most favorite question from one of the most favorite topics, that is nitrogen. So the correct sequence of steps in the process of mineralization, is nitrification, ammonification, aminization, nitrification, ammonification, aminization, aminization, ammonification, nitrification, and nitrification, ammonification, aminization. So can you tell me the correct answer? These are very easy questions. I think we will be very thorough with this. With the exam just at the door, I don't think there should be any problem with questions like this. Yes. Perfect. It is option C. Nothing much to worry about. So the correct answer is, of course, aminization, ammonification, and nitrification. Here you can see this picture. This picture I have taken from Tisdale and Nelson. You know, the best book of soil fertility. Of course, it is Tisdale and Nelson. This nitrogen cycle is from Tisdale and Nelson. And here you can see specifically it has been written. First, it is aminization, then it is ammonification, and then it is nitrification. I think it is not the perfect time to explain the whole process, but as you all know, aminization, it is already hidden in the word. Aminization means formation of amino acid from organic matter or from complex protein, formation of amino acid, that is RNH2. Then ammonification is nothing but formation of ammonia or ammonium. So amino acid, then the formation of ammonium ions is ammonification, and from ammonium to nitrite and then to nitrate is nitrification. We all know that. So the sequence is aminization, ammonification, nitrification. All right, moving on. In USLE, that is universal soil loss equation, R indicates, we all know universal soil loss equation is RKLSCP, and the R indicates. Here I will ask 2 supplementary questions with this. USLE was given by, you have to tell me the name of the scientists, and given in, you have to tell me the year. So you tell me the options and also you tell me these 2 questions. Given by, given in which year? Yes, I know you all know this. This is correct answer. Of course, R is rainfall erosivity. That is the easy one. No, not only Smith, Anil. It is not only Smith. You have to tell me the whole. Wishmeyer and Smith, perfect. 1978. Yes, Vipin, perfect. You are on perfect track. It is 1978. The year is also important. You can expect the year in some match the following, and it was given by, here you can see it was given by Wishmeyer and Smith. This is taken from old ISSS. I'm not going to explain all the things. You all know what is R, what is K, what is L, what is S, and what is C, and what is P. This is very important from soil erosion. You can expect at least 1 or 2 questions from USLE, and also the wind erosion equation. Uske bare mein bhi question aage aayega. So the persistent fraction of humus in soil is, this set is, very nice. I think you guys will like this set. So what is the persistent fraction of humus in soil? Is it fulvic acid, it is humic acid, it is none, or is it both, all of the above? Anyone? This question you can tell is a bit tricky. You are writing humin, Rohit. Humin लिखने से कैसे होगा? कौन सा option है humin? Huh? Which option is humin? Yes, okay, it's humin, but in this question it is none, right? You cannot say it is humin. So it will be none of the above. Anyone who has started studying soil science, who has read soil organic matter, definitely knows about this, but only for your, no, Anil, it is not B, it is not humic acid. Humic acid is intermediate, none, it will be humin. So for your help only, I have taken this. The 3 fractions of humic substances, as you all know, fulvic acid is the lowest molecular weight and it is the labile fraction. Then humic acid is the intermediate fraction, and finally humin is the persistent and the most insoluble fraction. We all know fulvic acid is soluble in all. Fulvic acid, what type of person is that? Person? Who is person here? I am not getting what are you writing. So fulvic acid is, all you know, it is the lowest molecular weight and it is soluble in everything. Everything means acid, alkali and water, whereas humic acid is only soluble in alkali, whereas humin is insoluble in everything, right? That is persistent. Moving on. Okay, we get a assertion reason question very early, and this is one of the good questions. I like this question. Let's see how good you have understood the concept. Huh? As the mobility of a nutrient in the soil increases, as the mobility increases, the amount of that nutrient needed in the soil to produce maximum yield increase. Mobility बढ़ रहा है, amount needed भी बढ़ रहा है. Okay, that's an interesting statement. Second statement is the law of Mitscherlich for elements like P and K, which are relatively immobile in soil, brought the concept of Bray's nutrient mobility. That's a very beautiful question, I must say. It will test your concept. Otherwise, if you don't know the concept, I don't think you can answer this. So tell me, I think this type of questions, which is a bit tricky and a bit, it's a bit lengthy, in that you have to go word by word. You see whether in any word, whether they have put any not or put anything negative that might make it incorrect, all right? So you go word by word. Mobility of a nutrient in the soil increases. यहाँ पे कुछ नहीं है. Mobility of a nutrient in the soil increases, okay. Amount of that nutrient needed in the soil to produce a maximum yield increase. Is it correct? No one is writing the answer till now. What happened? Write the answer. And Mitscherlich's law for elements like P and K, which are relatively immobile in soil, brought the concept of Bray's nutrient mobility concept. Is it correct? What about the 2 statements? Why is no one writing the answer? What is the problem? Statement 1 is false. And what about statement 2, Rohit? Well, we cannot waste much time. I'm not getting any answers. Option B, statement 2 is true. So Satya is saying option B, both statement 1 and 2 are false. No, this is not the correct answer. Rohit is saying statement 1 is false, statement 1 is true. Anil is telling statement 1 is correct, but statement 2 is false. Wow, lots of answers. We are getting 3 different combinations already. So let's see. Yes, of course, Rohit, you are correct. Statement 1 is false, but statement 2 is true. All right. Why? We will see. अब देखो स्टेटमेंट 1 में तो समझने के लिए कुछ है नहीं, दिस इज सिंपल थिंग कि मोबिलिटी ऑफ ए न्यूट्रिएंट इन द सॉइल इंक्रीजेस, द अमाउंट ऑफ दैट न्यूट्रिएंट नीडेड इन द सॉइल टू प्रोड्यूस अ मैक्सिमम यील्ड इंक्रीज। ये कभी हो नहीं सकता, सो दिस इज डेफिनेटली फॉल्स। ऑलराइट, मोबिलिटी अगर बढ़ रहा है, मोबिलिटी अगर बढ़ रहा है तो जितना भी न्यूट्रिएंट है, हाउ मच एवर स्मॉल इट माइट बी, it can move, right? It can be mobile and it can go to the plant root and it can be absorbed. So इसका कोई मतलब नहीं है मोबिलिटी भी बढ़ रहा है और उसका अमाउंट नीडेड वो भी बढ़ रहा है, ये कभी हो नहीं सकता। It should have been decrease or it should have been either of the word would have been decrease. So first statement में तो देखो कुछ नहीं है, that is a very easy statement, that is false. What about the second statement? The second statement demands your concept, you should know. That's why I have written here. You can read statement 2 accurately reflects the historical development of Bray's concept. तो अभी यहाँ पे बोल रहा है the law of Mr. Mr. law क्या है? Mr. law we know it is diminishing returns. It says log of a minus y is equal to log a minus cx. It assumes that plant response to a nutrient follows a specific predictable curve where the proportionality constant remains constant. मतलब इसका मतलब क्या है? If mobility decrease then yield increase. No, ऐसा कुछ नहीं है। मोबिलिटी अगर ज्यादा है तो वो न्यूट्रिएंट अगर सॉइल में कम भी होगा, इट कैन प्रोड्यूस द मैक्सिमम यील्ड बिकॉज वो मोबाइल है, वो यहां से यहां पहुंच सकते हैं। लेट मी मेक इट मोर इजी, सपोज एक न्यूट्रिएंट यहाँ पे है और प्लांट न्यूट्रिएंट यहाँ, प्लांट का रूट्स यहाँ पे है, ठीक है। नाउ इफ दिस इज मोबाइल, दिस कैन ट्रेवल हियर एंड इट कैन गो, नो इट कैन टेक अप बाय द, इट कैन बी टेकन अप बाय द प्लांट। लेकिन अगर वो जो न्यूट्रिएंट है वो अगर इमोबाइल है, तो इमोबाइल है वो तो यहीं पर ठहर जाएगा ना, इट विल नॉट ट्रेवल टू द रूट। So immobile nutrient will be needed in more amount to make the maximum yield. But अगर mobility बढ़ जाएगा तो amount of nutrient needed in the soil to produce maximum yield increases. इसका ये नहीं है, all right. So जो statement 2 का हम बात कर रहे थे, Bray observed that Mr. Leake's equation worked reasonably well for relatively immobile nutrients like P and K, where the plant's ability to forage and the concentration gradient dictate uptake. However, Bray noticed that Mr. Leake law failed in case of highly mobile nutrients and उसके केस में law of minimum लागू होगा. All right. So this is a very important part. I would like all of you to note this. We all know law of minimum given by Liebig. All right. This is valid for mobile nutrients. All right. Law of minimum क्या बोलता है? If all but one of the essential is not present, the crop will be barren. Whereas sorry, not Mr. Lick. Whereas Bray's law all right, यहाँ पे तुम देख सकते हो, however Bray noted that Mr. Leake's law failed to accurately describe the response to highly mobile nutrients, whereas it is very accurate for relatively immobile nutrients. All right, so we are on the question now. I don't think we can go more than this. अभी भी अगर किसी को doubt है, you can definitely ask in the comments. I will give you reply. Do not worry, I will make you understand this, maybe in the marathon also. All right, अभी के लिए let's move on. Ammonia volatilization capacity of the following soils are such that, this is also a very easy question. I don't think you will be needing much time for solving this. Can you please tell? Ammonia volatilization capacity of the following soils are such that, Aman Kumar is telling B, Anil Jat is telling B, alkaline, calcareous, acidic. I don't agree with you. ये दोनों तो नहीं होगा, that is पक्का, because acidic soil लास्ट में होगा, fine. लेकिन calcareous और alkaline में कौन आगे आएगा? Who will be the first? You are saying alkaline, calcareous, acidic. No, the correct answer is calcareous, alkaline and acidic. It will be option 1. All right. अब this equation, I don't think anyone needs to be like किसी को बताने का जरूरत नहीं है. This is the simple equation of ammonia volatilization. Ammonium ion है, उसके साथ OH minus जुड़ रहा है, तो ammonia हो रहा है प्लस वाटर हो रहा है, right? So simple ले शैटेलियर प्रिंसिपल जो है ये इक्विलिब्रियम कंडीशन में है, तो अगर OH माइनस बढ़ जाएगा, OH माइनस इफ इट इंक्रीजेस देन द रिएक्शन विल मूव टुवर्ड्स दिस साइड, यानी कि जितना pH बढ़ेगा उतना अमोनिया वोलेटिलाइजेशन बढ़ेगा. दिस इज पक्का. सो एसिडिक सॉइल विल हैव द लीस्ट. दिस इज डन. नाउ व्हाई, व्हाट बिटवीन कैलकेरियस एंड अल्कालाइन में अब क्या सीन है देखते हैं. See, calcareous soil has the highest volatilization capacity. Why? Calcareous soils are typically alkaline. They have pH of 7.5 to 8.5. We all know that. That is typically alkaline. Their specific mineralogy creates the highest overall capacity for volatilization. The defining characteristic is the presence of free CaCO3. Calcareous soil में जो free CaCO3 है, उसके वजह से ammonia volatilization is higher. How? You can see here, this equation. All right. When ammoniacal fertilizers are applied, a specific precipitation dissolution reaction occurs. ये अमोनियम सल्फेट है, अमोनियम सल्फेट फर्टिलाइजर हमने डाले कैलकेरियस सॉइल में, कैल्शियम कार्बोनेट के साथ वो रिएक्ट किया, इट फॉर्म्स अमोनियम कार्बोनेट प्लस कैल्शियम सल्फेट. दिस रिजल्टिंग अमोनियम कार्बोनेट, ये जो अमोनियम कार्बोनेट यहाँ पे आया, दिस इज हाईली अनस्टेबल इन द सॉइल प्रोफाइल एंड रैपिडली डिसोसिएट्स, ड्राइविंग सीवियर वोलेटिलाइजेशन. दिस अमोनियम कार्बोनेट लीड्स टू huge amount of volatilization by means of this equation. All right. Furthermore, the continuous dissolution of CaCO3, calcareous soil है, CaCO3 है, उसका dissolution तो होगा ही. It provides a strong localized buffering capacity. This is very important. This part is extremely important. You know, during urea hydrolysis, the localized microsite pH spikes. We all know urea का जब hydrolysis होता है, तब उसका इर्द गिर्द में whatever the surrounding system, उसका जो pH है वो बढ़ता है. While non-calcareous soil might naturally acidify and self-regulate due to the buffering capacity of soil, soil का जो normal buffering capacity है, उसके वजह से जो normal soil है, it might give a buffer, whereas the CaCO3 buffers against this pH drop, sustaining the highly alkaline microsite condition that prolong and maximize the NH3 loss. All right. If you read this PPT very well, you will find this explanation. This is the best explanation I could found, and this is the reason why it will be calcareous, then alkaline, and then acidic. All right. किसी को अभी भी अगर कुछ डाउट है, you can definitely ask in the comments. मतलब ये लाइव चैट में नहीं, वीडियो का कमेंट में जाके पूछना. I will be there for answering that. Don't worry. All right. Now इस क्वेश्चन में we will take exactly 10 seconds. Which of the following is deficient in waterlogged soil? Iron, manganese, zinc, all of these. What will be the answer? Iron, manganese, zinc, all of these. Deficient in waterlogged soil. Yes, Vipin Yadav is telling option D. All of these. No. It is not at all of these. भाई पैडी सॉइल, वाटरलॉग्ड सॉइल में आयरन का टॉक्सिसिटी होता है भाई. Fe का टॉक्सिसिटी होता है. Fe is hugely available. This toxicity of iron in waterlogged soil, जिससे ब्राउनिंग डिजीज होता है. What are you writing, man? Zinc. Divya is writing B. Manganese. Manganese. What? It is not manganese. Nikhila, why are you deleting the message? Yes, it is zinc. The answer is zinc. You all know, right? Like nitrogen, it is the most deficient nutrient in the Indian soils, and most deficient micronutrient in Indian soil is zinc. Now this zinc widespread deficiency is found in waterlogged soil, जिसके वजह से which disease happens? अरे यार, तुम लोग तो confuse हो जा रहे हो. Don't get confused. Waterlogged soil, zinc deficiency, this is a very well-known phenomenon. इसमें which disease of paddy happens due to zinc deficiency? Tell fast. It is, Nikhila, do not delete the correct answer. You are correct only. Keep it correct. Yes, Khaira disease. ये बोलने में इतना टाइम क्यों लग रहा है भाई? This is like the basics only. सी वाटरलॉग सॉइल में जिंक का डेफिशिएंसी क्यों होता है ना? दिस क्वेश्चन माइट कम इनटू योर हेड फर्स्ट. सो इसका मेजर जो रीजन है दैट इज जिंक. अगर देखोगे जिंक कैन ओनली एग्जिस्ट इन Zn2+ फॉर्म. व्हाई जिंक कैन ओनली एग्जिस्ट इन Zn2+ फॉर्म? बिकॉज इसका 3d10 कॉन्फ़िगरेशन है. जाके जिंक का इलेक्ट्रॉनिक कॉन्फ़िगरेशन देख लेना. 3d10 4s2. तो ये 2 इलेक्ट्रॉन ये बाहर जा सकता है, ये 10 को हम हाथ नहीं लगा सकते. सो हाँ, कोई बात नहीं, कंफ्यूज तो हो ही सकते हो. ओरिजिनल एग्जाम में कंफ्यूज मत करना, अभी कंफ्यूजन अलाउड है. So zinc can only exist in one redox state, that is Zn2+. Zn तो इसका ना ऑक्सीडेशन हो सकता है, इसका ना रिडक्शन हो सकता है. ठीक है, we all know this. Whereas Fe and Mn they can stay in. Fe का तो पता है, Fe2+, Fe3+. मैंगनीज can stay in 4+, है ना? Then KMnO4 में क्या है? KMnO4 में 7+, है ना? So they have multiple oxidation states. इसके वजह से क्या होता है? When waterlogging happens, we know the redox, जो redox है यानी जो EH है, that EH drops hugely. इस drop के वजह से क्या होता है? ये जो Fe3+ है, ये जो Mn7+ है, सबका रिडक्शन होता है. Everything gets reduced. अब जिंक के पास तो रिड्यूस होने का कोई चारा नहीं है ना. It cannot get reduced. It has only one state. So ये लोग रिड्यूस होने के बाद हाईली मोबाइल और हाईली अवेलेबल हो जाता है. So this iron and manganese becomes hugely available और कॉम्पिटिटिव इंटरफेरेंस की वजह से जिंक इज लेस अवेलेबल. जिंक को प्लांट नहीं ले पाता. जिंक गेट्स डेफिशिएंट. ये हुआ एक रीजन. दूसरा रीजन क्या होगा? दूसरा रीजन यू विल कम एंड स्टडी इन पीएचडी. पीएचडी का जो फर्स्ट कोर्स है उसमें पढ़ाया जाएगा फॉर्मेशन ऑफ ZnCO3, फॉर्मेशन ऑफ ZnS. ये सारे मिनरल्स बनता है और उसका प्रेसिपिटेट हो जाता है. दैट्स व्हाई अगेन जिंक बिकम्स अनअवेलेबल. बिकॉज जो रेडॉक्स है देयर इज अ स्पेसिफिक पैरामीटर, इट इज कॉल्ड Pe+pH. हम लोग तो सिर्फ pH जानते हैं, बट देयर इज अ पैरामीटर कॉल्ड Pe+pH दैट डिटरमाइंस कौन सा मिनरल का प्रेसिपिटेशन होगा, कौन सा मिनरल का सॉल्यूशन होगा. सो दिस ZnCO3 ZnS का प्रेसिपिटेट हो जाने की वजह से दिस जिंक गेट्स अनअवेलेबल. एंड थर्ड रीजन इज ये जो आयरन बहुत ज्यादा एक्स्ट्रा अवेलेबल हो जाता है, दिस आयरन मेक्स अ प्लेक अराउंड द प्लांट रूट्स. प्लेक का मतलब समझते हो ना? इट्स लाइक अ लेयर. ऐसा एक लेयर बना देता है राइस रूट्स के पास, जिसके वजह से Zn का अपटेक गेट्स हैम्पर्ड. सो फॉर दिस 3 रीजंस जिंक इज हाईली डेफिशिएंट न्यूट्रिएंट इन वाटरलॉग्ड सॉइल्स. ऑलराइट, इतना बोलने का कोई जरूरत नहीं था, बट आई थिंक यू शुड नो. This is a question from agrometeorology. Agrometeorology is also an important part for JRF, as you all know. Who is the first scientist? This is a very basic question. Who attempted to classify the climate? Tell me. What will be the answer for this? Who is the first scientist who attempted to classify the climate? अरे मेटेरोलॉजी पढ़ना छोड़ दिए हो क्या तुम लोग? मेटेरोलॉजी भी पढ़ना है भाई. इट इज इन द सिलेबस. इट माइट कम. यस निखिला. Yes, yes, yes. All of you are absolutely correct. इसमें कोई टाइम जाया नहीं करेंगे. Of course, it is de Candolle, you know. For you all, I have taken the explanation. इनका पूरा नाम था अल्फोंस डी कैंडोल, जिन्होंने he made the first modern scientific attempt to classify climate by using global vegetation as an index. ये important है, इसको याद रखना. किस बेसिस पे डिवीजन किया गया था? That is global vegetation as an index. He recognized all and distinct botanical zones based on temperature and moisture requirements, जिसमें आता था मेगाथर्म, मेसोथर्म, माइक्रोथर्म, हेकाइस्टोथर्म and xerophytes. All right? Yes, yes, yes. Anil, very good, very good. ऐसे करते रहना. Which of the following crop is susceptible to application of potassium chloride? यानी कि KCl, यानी कि MOP. MOP से कौन susceptible है? These questions are only one second questions. इसमें कोई no time to waste. Yes, option D. इसमें तो कुछ नहीं है. We all know this is option D. अब ये option D क्यों है? I think all of you know. because tobacco का जो burning quality है, that burning quality gets deteriorated by Cl minus ions, and potato का जो है उसका starch gets deteriorated by Cl minus ions. That is why you should apply SOP in potato and other tuber crops and tobacco. All right. PF refers to probably the easiest question from soil physics that the question setter would have found. So fast. These questions are sitter only. These are for giving you marks. कितना जल्दी इसको करके तुम निकल सकते हो उस हिसाब से रैंक आएगा, you know. ऑप्शन बी इसमें कुछ बोलने का नहीं है. दिस इज वेरी इजी. आई हैव गिवन यू द सोर्स. न्यू ICCS पेज 179 में है दिया हुआ. Here you can write. Here you can see that gave the symbol Schofield. ये आता है. Important जो पार्ट है वो मैं मार्क कर रहा हूँ. किसने दिया था important है, कब दिया था important है. Who suggested the use of logarithm of soil moisture tension and gave the symbol PF of this logarithm, which is an exponential expression of free energy difference based on the height of water column above free water level in centimeter. ये भी important है. Unit जो यहाँ पे height of water column है उसका unit होना चाहिए सेंटीमीटर. दूसरे यूनिट में अगर करोगे तो नहीं होगा. Sir, which soil texture will be more prominent to soil crusting, silty loam or silty clay loam? अरे मेरे ख्याल से it is silty clay loam because as the clay content will increase, you all know the crusting will increase, but I cannot say for sure. इसका अगर कहीं पे source मिले तो देखना. I think it is silty clay loam. All right. तो यहाँ पे जो थे इसका यूनिट याद रखना है, नेम ऑफ साइंटिस्ट याद रखना है, एंड ईयर कब दिया गया था वो याद रखना है ना. एंड यहाँ पे जो ये जो कैलकुलेशन दिया हुआ है, दिस ऑल्सो यू कैन सी. इफ यू हैव एनी प्रॉब्लम विद अंडरस्टैंडिंग हाउ पीएफ कैलकुलेशन एक्चुअली वर्क्स, तो ये लास्ट लाइंस पढ़ना. दिस इंडिकेट्स 1000 सेंटीमीटर ऑफ वाटर कॉलम हाइट. ठीक है. Moving on, which of the following formula is correct? This question is from agronomy and this question is straight from RS Meena. I don't know. ChatGPT suggests silty loam and some test series suggests silty clay loam. यार ChatGPT से पढ़ाई मत करो भाई. ChatGPT Pro version अगर है तो उसमें देख सकते हो, but do not believe blindly what ChatGPT is saying. Our soil science is very far from ChatGPT, you know. यहाँ पे whatever is written in ICCS, whatever is written in TD Vishwas, that is only our Bible. We cannot change ourselves. All right. You tell me the answer of this agronomy. अरे soil science तो सबको आता है तुम लोगों को. I know you are soil science students. Tell me the answer of this. Which of the following formula is correct? यहाँ पे WR IR क्या है ये सब तो पता होगा ही तुम लोगों को यार. Exam is just 1 month भी नहीं है, like 1 month है, 1 month 3 days. I cannot see any answers till now. Wow. What man? Answers नहीं आ रहा है क्या? Is it not showing? Hello. Please write the answer. I think there might have been some problem. I cannot see the answers. So इसका आंसर होगा B and C both. If you see, the setter has mixed up the equations. Both option B and option C both are correct. If you see, IR क्या है? IR is irrigation requirement, which is equal to water requirement minus effective rainfall plus water supplied by soil. All right. इसी इक्वेशन को इसको उल्टा कर दो, इस WR को इधर रख के इसको इधर लेके चले जाओ. So WR is equal to IR plus ER plus S. So both of these options are correct. If you mark any one of these, that's fine. No problem. Moving on. Now it is a statistics question. Option C. इतना देर बाद आंसर आ रहा है. Is there any glitch? I don't know. What's the problem? There might be some glitch. Anyhow, this is a question from statistics. Statistics is very, very, very important. Abhi you are entering the life of higher studies, and this statistics will continue to follow you until your PhD and until your everything. So you have to tell me the answer of this. Okay, Pawan and Anil, it is saying option D, split plot design. Wow, that's a very nice answer. Yes, it is correct. It is split plot design. Do you guys want to know split plot design क्या है, उसमें क्या होता है, or should I move on? If you want to know, then only I will tell. Otherwise, I will not waste much time. We will go on solving the questions. Completely randomized design क्या है, Latin square design क्या है, factorial RBD क्या है? Are you guys thorough with this? Do you know what is this? अरे explain यार, explain का तो time. All right, if you are saying explain, why not? Split plot design हम कब use करते हैं? Split plot design हम तभी use करते हैं when we have two factors under study simultaneously. ठीक है ना? यानी कि एक साथ हमें दो फैक्टर की स्टडी करना है. That is, एक साथ अगर more than one factor की अगर एक साथ स्टडी करना है, so that comes under factorial experiment. All right, here you can see the word factorial. Factorial मतलब more than one factor, जिसमें एक फैक्टर का कई सारे लेवल्स भी हो सकता है. So what is the difference? अब two factors under study ये तो है, but उसमें से precision is, उसमें से there is one main plot and there is one subplot. So split plot design हम तब यूज करते हैं जब हमारे पास space constraint हो. Any researcher cannot have unlimited space, है ना? उसके पास there is some confined space only, some confined experimental unit, confined resource. उसी के अंदर उसको experiment करना है. So दो फैक्टर है, लेकिन दो फैक्टर का दोनों का ही प्रिसिशन हमें सेम नहीं चाहिए. ऑलराइट, एक का प्रिसिशन थोड़ा एकदम एक्यूरेट चाहिए, एक का प्रिसिशन थोड़ा कम होने से चलेगा. इन दैट केस जिसका प्रिसिशन कम होने से चलेगा उसको हम मेन प्लॉट असाइन कर देंगे. द मेन प्लॉट्स विल बी बिग. उस मेन प्लॉट के अंदर वी विल हैव सब प्लॉट्स, द सब प्लॉट्स विल बी स्मॉल. तो जो स्मॉल प्लॉट है उसका प्रिसिशन ज्यादा होगा. सो द फैक्टर जिसका प्रिसिशन हमें ज्यादा चाहिए दैट वी विल पुट इन सब प्लॉट, और जिसका प्रिसिशन हमें कम चाहिए that we will put in main plot. So here you can see factorial RBD से भी हम more than one factor कर सकते हैं, to study two factors. ये factorial RBD से भी कर सकते हैं, but here you can see different level of precision, different level of precision, है ना? अब इसका अगर एक एग्जांपल दिया जाए तो से दो फैक्टर हम ले लेते हैं. पैडी का एक एक्सपेरिमेंट है. पैडी का एक एक्सपेरिमेंट में वी आर टेकिंग ट्रांसप्लांटेड पैडी एंड डायरेक्ट सीडेड पैडी. सो इसका हमें प्रिसिशन उतना ज्यादा नहीं चाहिए. तो जो मेन प्लॉट है उसमें हम ट्रांसप्लांट और जो डायरेक्ट सीडेड है उसको कर दिए. फिर जो सब प्लॉट है उसमें हम इरिगेशन लेवल्स को अलग अलग कर दिए, बिकॉज उसका प्रिसिशन ज्यादा जरूरी है. सो दैट इज अ स्प्लिट प्लॉट. और दोनों का अगर प्रिसिशन हमें सेम चाहिए, we cannot compromise on precision of a factor, then we have to go for factorial RBD. Or Latin square or CRD, I don't think I need to tell. These are basic designs. CRD, you know, it is the simplest design, जिसमें ना कोई replication है, ना कोई repetition है, कुछ नहीं है, only treatments. And Latin square design is two-way blocking, है ना? A B C D E, A B C D E, ऐसे करके the Latin square. I think you will get to know this. ज्यादा इंपॉर्टेंट नहीं है, बट इसको याद रखना. दिस इज अ इंपॉर्टेंट क्वेश्चन. दिस क्वेश्चन वी विल एग्जैक्टली टेक 5 seconds. इन सॉइल माइक्रोन्यूट्रिएंट एक्सट्रैक्टेंट ऑफ 0.005 मोलर DTPA. व्हाट इज द pH? व्हाट इज द pH? सेवन 7.6 कौन लिख रहा है यार? 7.6 नहीं है भाई. 7.6 क्यों लिख रहे हो? You're writing option A and you are writing 7.6. Definitely it is 7.3. हाँ, given by Lindsay and Norwell तो सब ठीक है, but it is 7.3. 7.3 here. अच्छे से इसको देखो. एनालिटिकल केमिस्ट्री इज एक्सट्रीमली इंपॉर्टेंट. एनालिटिकल केमिस्ट्री में बहुत ज्यादा थॉरो होने की जरूरत है, वहां से बहुत सारे क्वेश्चन आते हैं. 7.6 तुम लोग एबीडीटीपीए के साथ आई थिंक यू आर मिक्सिंग इट अप. जो यूनिवर्सल एक्सट्रैक्टेंट है अमोनियम बाइकार्बोनेट डीटीपी एबीडीटीपीए गिवन बाय सुल्तानपुर एंड श्वाब, उसमें 7.6 है. बट नॉर्मल डीटीपीए जो 0.005 मोलर डीटीपीए का जो हमारा लिंडसे एंड नॉर्वेल 1978 एक्सट्रैक्शन है, दैट इज 7.3. अब ये pH 7.3 क्यों होता है? यहाँ पे CaCl2 का क्या जरूरत है? यहाँ पे TEA का क्या जरूरत है? All this you should be very thorough, and everything is written in old ISSS. I am not telling you some rocket science. It is written in old ISSS. Go and read that thoroughly. That chapter is extremely important. वहां से question आएगा, वहीं पर rank decide होगा. Because most of the people don't understand and they don't remember. All right. Be very thorough with that. Be very thorough with analysis. That is extremely needed. Acid sulfate soils, also known as, these questions are feeling like, yes, you are correct. एबीडीटीपीए के साथ डीटीपीए का कंफ्यूजन हो गया, लेकिन मत करना, है ना. एबीडीटीपीए 7.6 है, that is ammonium bicarbonate, that is the universal extractant. C कैटले. This is a BSc second year level question. इसमें हम लोग कुछ बात नहीं करेंगे. We all know it is called cat clays. Dutch refers as cat clay. और इसका क्यों cat clay बोलता है, I think all of you know, because वो शाइन करता है. दे शाइन लाइक कैट साइज, यू नो. कैट का जो आंख होता है वो उसके जैसा शाइन करता है. दैट सॉइल, दैट इज व्हाई इट इज कॉल्ड कैट क्लेस. Targeted yield approach was given by, again, another undergraduate level question. Undergraduate level question, tell fast. Undergraduate means first year undergraduate level question. I'm not telling JRF aspirant, of course. Ramamurthy, yes, all of you are correct. This is taken from new ISSS. New ISSS का जो fertility evaluation है, written by Dr. B.S. Dwivedi, that chapter is very good. I would suggest all of you to read that. Fertilizer recommendation based on targeted yield concept, initially advocated by Truog. ये भी important है, इसको भी याद रखना. It was initially advocated by Truog and further improved by Ramamurthy et al. In 1967. All right, moving on. यहाँ पे Kate and Nelson के साथ do not confuse. Kate and Nelson ने क्या दिया था? Kate and Nelson ने क्या दिया था? Be very fast. Yes, critical limit, critical soil test approach, critical limit approach. तो इसको याद रखना, ठीक है ना. Denitrification occurs under aerobic, anaerobic, both. Denitrification occurs under, Spurti is telling B, Pavan is telling both, Aman and Vipin is telling B, Anil, Divya, all are telling B. Yes, all of you are correct. It will be B only. ये सब both के चक्कर में मत पड़ना भाई. Denitrification is anaerobic only. Denitrification is a process limited to anoxic soils. This has been taken straight from ISSS. अगर ऑक्सीजन होता, अगर सी डिनाइट्रिफिकेशन का जो बैक्टीरिया है, those bacteria are facultative aerobe. Yes, Aman, I know you have read that those are facultative anaerobe, but प्रोसेस पूछ रहा है. डिनाइट्रिफिकेशन कहां होता है? फैकल्टेटिव एनारोब का क्या मतलब है? फैकल्टेटिव एनारोब का मतलब है कि दे कैन बी बोथ एरोबिक एंड एनारोबिक. अब ये एरोबिक एनारोबिक व्हाट आर दे नीडेड फॉर, मतलब क्या चीज है एरोबिक एनारोबिक? जिसको ऑक्सीजन चाहिए दैट इज एरोबिक, जिसको ऑक्सीजन नहीं चाहिए दैट इज एनारोबिक. अब ऑक्सीजन किस लिए चाहिए? व्हाई वी नीड ऑक्सीजन फॉर रेस्पिरेशन? बिकॉज ऑक्सीजन एक्ट्स एज द टर्मिनल इलेक्ट्रॉन एक्सेप्टर. Oxygen will accept the terminal electron of the respiration and itself will get reduced to carbon dioxide like our human respiration. We are taking oxygen, that oxygen is accepting the terminal electron and we are releasing it as carbon dioxide. वो एरोब्स का बात है. अब एनारोबिक रेस्पिरेशन जो डिनाइट्रिफिकेशन है उसके केस में क्या होता है? ऑक्सीजन नहीं है, ऑक्सीजन इज नॉट देयर. दैट इज व्हाई द बैक्टीरिया आर टेकिंग द नाइट्रेट. They are using nitrate as the substrate and they are using nitrate as the terminal electron acceptor. So in place of oxygen they are using nitrate. So अगर ऑक्सीजन वहां पे अवेलेबल है, ऑक्सीजन अवेलेबल है तो दे विल यूज ऑक्सीजन ओनली बिकॉज दे आर फैकल्टेटिव एनारोब. दैट यू आर करेक्ट. लेकिन अगर ऑक्सीजन यूज किया तो वहां पे N2O, वहां पे N2, ये क्या फॉर्म होगा? ये तो फॉर्म नहीं होगा ना. ऑक्सीजन अगर यूज किया तो CO2 फॉर्म होगा. only and only if they use nitrate, then only N2O and N2 will form. और nitrate use अगर करेगा, कब करेगा? They will only use under anaerobic condition. So denitrification occurs only under anaerobic condition. ठीक है अमन? I think you are thorough now. इसमें कोई समस्या होने की और बात तो होना नहीं चाहिए. Moving on. What do you mean by brown mulching? This is also a very exam-worthy question. Like you might get this in exam. So this is also a very exam-worthy question. Tell me, what do you mean by brown mulching? Yes, very exam-worthy question, but it is very easy also. So I can already see the answers. Aman, did you understand? You are not telling. Did you understand, Aman, what I told for the last slide? Yes, Spurti, Aishwarya, everyone is correct. It is option B only. Yes, very good. Thank you, Aman. What is brown mulching? Brown mulching is also referred to as brown manuring. इसको भी याद रखना. It is a no-till version of green manuring. तो इसमें क्या होता है? इसमें पहले green manure crop उगाया जाता है, fast growing legume like sesbania rostrata or whatever, alongside a primary cereal crop. After 25 to 30 days, the legume is knocked down using a selective post-emergence herbicide like the 2,4-D. This desiccated plant material is left on the soil surface without mechanical incorporation. यानी कि after application of the herbicide, उसको हम अलग से incorporate नहीं करते. We just keep it in the soil as it is. As the plant residues lose their chlorophyll and die, they turn brown. Hence the term brown mulching. So it acts like a mulch. Since we are not incorporating it with the soil, it acts like a mulch. That is why it is called brown mulching. And it is no-till plus herbicide plus mulch. All right. This is a very exam-worthy question. आने का बहुत ज्यादा chances है. So be very thorough. All right. Be very thorough with all these. What is brown mulching? What is brown manuring? What is green manuring? है ना? This is again a BSc first year question. There is nothing. ICP AES and flame photometer. ICP AES का full form नहीं दिया question setter ने. वो अगर दे देते तो इस question में और कुछ नहीं रहता. But anyhow, ICP AES and flame photometer works on. जल्दी से बताओ भाई. इसमें कुछ नहीं है. स्फूर्ति सी लिख रहे हो. Absorption emission spectroscopy क्या होता है? सत्य. Why it is absorption? अरे यार. What is making you write absorption emission spectroscopy? पहली बात तो adsorption spectroscopy नाम का कोई चीज नहीं होता. It is not adsorption. All right. It is absorption. है ना? So B और D तो यहाँ पे already it is wrong. Adsorption spectroscopy does not exist. All right. दूसरी बात है absorption spectroscopy में आता है spectrophotometer, फिर colorimeter, फिर double AS. इसमें आता है absorption spectrophotometry. और flame photometer and ICP AES, these are the examples of emission spectroscopy. What is so hard in that? Why would you write C? It is definitely emission spectroscopy. Do you have any doubt in what is emission spectroscopy and what is absorption spectroscopy? Should I tell you? If you want only, then I will tell. Otherwise, the time is a bit short. We cannot. आपको अगर चाहिए तो बताओ. I will explain. Very short. Aman is telling yes, sir. ठीक है. अब yes, need. All right. Fine. Concentrate then. We will use a new page for that. This question is extremely important. अभी तो तुम लोग JRF लिख रहे हो. JRF में तो important है ही. JRF के बाद whatever exam will be there, JRF, SRF, then you will go on writing ARS. In everywhere, in this year's ARS and in last year's ARS, this question has only come. What is the difference between absorption spectrophotometry and emission spectrophotometry? All right. So be very thorough with the concept. Do not take it lightly. Emission का मतलब है कुछ emission हो रहा है. All right. इसका एकदम I will be very short because we have less time. So ध्यान से सुनना है ना, बी वेरी अटेंटिव. Say we will take the element Na or K. We know for कोई एक एलिमेंट को लेते हैं and that element we know उसका जो एटम रहता है, the atoms are like this. All right, this is the nucleus and these are the orbitals in which there are electrons. All right, so emission spectroscopy का क्या फंडा है, ये जब when this atom of this element, when this atom of this element is in neutral state, it is in ground state, then the electrons are in its designated orbital. Designated orbital में electrons है ना, when it is in ground state. Normally जैसे नेचर में एटम रहता है उसी हिसाब से है. Then emission में हम क्या करते हैं, we supply some energy by means of flame, in case of flame photometer, by means of plasma in case of ICPOES, है ना. ICPOES जो था उसका फुल फॉर्म क्या है, इंडक्टिवली कपल्ड प्लाज्मा एमिशन स्पेक्ट्रोस्कोपी. ऑलराइट, तो हम यहां से एनर्जी सप्लाई दिया. Then with the energy what happens, when this energy reaches, this electron becomes excited, and excited होके वो क्या करता है, it makes a jump. This phenomenon is called orbital jump. So this electron jumps and moves on to the next higher orbital. All right, ऐसा एक एटम है, वहां पे जो इलेक्ट्रॉन था, we supplied energy and that jumped to the next higher orbital. When it jumped to the next higher orbital, this element becomes excited. Now we all know in this universe no one likes to stay excited, है ना. हम स्टूडेंट्स लोगों की बात अलग है, we can stay, but not the elements. They do not want to be excited. क्योंकि excited में क्या प्रॉब्लम है, because the electron is on the higher shell, उसमें एनर्जी ज्यादा लग रहा है. No one wants to spend energy, है ना. Whatever you do, सबसे ज्यादा सुकून मिलता है when you are in the bed with a nice AC and a nice blanket, right? So इसको भी मन है to go back to the ground state. So for going back to the ground state, what does it need to do? Again, this electron will come back to its original orbital. But when this electron will come back to this original orbital, it will emit the energy that it had absorbed previously. पहले जो एनर्जी absorb करके ये जंप लगाया था, उसी एनर्जी को ये रिलीज करके फिर वापस आएगा. Now this release is characteristic. Characteristic का मतलब क्या है? For each element it is different and it is very narrow. So उसका color different होगा. So this color will tell you which element is there. We will detect this emitted energy. इसका color will tell the name of the element, और इस एनर्जी का इंटेंसिटी will tell कि amount of the element, सैंपल में कितना अमाउंट है. As we are measuring the emitted energy, that is why it is called emission spectroscopy. Is there any problem? Tell me, did you understand what is emission spectroscopy? क्यों इसका नाम emission है? हाँ? Did you understand or you need any other clarification? Yes sir, yes, very good, very nice. Electron था, electron energy लिया, energy लेके it jumped to the higher orbital, the atom got excited. This excited atom, when this electron jumps back to its original orbital and returns back to its ground state, यानी कि Na star से लेके जब Na हो जाता है, then it releases a characteristic wavelength of energy and that is what we measure, है ना. ये हुआ emission. Now what is absorption? Absorption तो और simple है. Absorption spectroscopy जब भी पढ़ोगे सबसे पहले दिमाग में जो आना चाहिए, that is the law that is governing that. All right, and that is Beer-Lambert's law. All right, Beer-Lambert's law वो क्या बोलता है? Beer-Lambert's law क्या बोलता है? Anyone? What does Beer-Lambert law say? कोई नहीं भाई, जाने दो. This is the Beer-Lambert law, है ना. Directly proportional to path length and concentration. Yes, this is called absorbance. Absorbance is directly proportional to concentration and path length. ये जो path length है, this path length was given by Lambert and this concentration was given by Beer. इसीलिए it is called Beer-Lambert law. तो इसका मतलब क्या है? What is the simplest मतलब of this? That we will tell. We will take some sample here. है ना? Sample में हम we will have a light source और यहाँ पे we will have a detector. ठीक है, तो यहां से हम स्पेसिफिक वेवलेंथ में लाइट छोड़ेंगे, स्पेसिफिक वेवलेंथ में लाइट छोड़ेंगे बेस्ड ऑन द कॉन्सेंट्रेशन ऑफ द सैंपल. जो हमारा टारगेट एलिमेंट है उस हिसाब से जो कॉन्सेंट्रेशन उसका है उस हिसाब से द इंटेंसिटी ऑफ दिस वेव विल गेट रिड्यूस्ड और उसको हम डिटेक्ट करेंगे. ठीक है, इसका बेसिक जो प्रिंसिपल है वो है we will take a normal liquid sample, so all atoms are in the ground state only, so all atoms are in the ground state. For spectrophotometer जो normal spectrophotometer है और जो normal जो colorimeter है उसमें we need colored samples. We have to develop a color because without color this absorption will not happen that good. क्यों? color में अगर हमने blue color दे दिया, say this solution is blue, so if this solution is blue and we are using a wavelength that is complementary to blue. complementary का मतलब क्या है? complementary का मतलब है if you draw a color filter like this, तो violet VBGYOR, this is called the color wheel. तो इसमें जो opposite है those are called complementary. तो इसके complementary कोई color around orange to red के wavelength में अगर हम कोई light दे दे, so that light will be maximum absorbed by this color and उसका intensity will get reduced. So यहाँ से अगर मान लो 3 intensity गया, so it will be 1 intensity. So based on this decrease in intensity, we know how much we have sent from the source and we know how much we are detecting. So दोनों का comparison करके we can tell how much it has been absorbed and how much it has been absorbed through this law. How much it has been absorbed, we can get this concentration value because this path length is made constant. This is a constant. And based on this absorbance value, we can tell what is the concentration. Since यहाँ पे light का absorption हो रहा है, we are emitting a light. यहाँ पे कुछ emit नहीं हो रहा है. This light source is there and we are simply emitting it through electricity. And this sample is absorbing. It is absorbing the light and reducing its intensity. That is why it is called absorption spectroscopy. Is it clear or you need any more? तो आई थिंक इट इज क्लियर नाउ. ये एमिशन है. एमिशन में एटॉम ऐसे जंप लगाएगा, फिर एटॉम वापस आएगा, एनर्जी छोड़ेगा, उस एनर्जी को हम मेजर करेंगे. दैट इज व्हाई इट इज एमिशन. एब्जॉर्प्शन में क्या होगा? एब्जॉर्प्शन में कोई कुछ जंप नहीं कर रहा है. एब्जॉर्प्शन में सिंपली वी आर सेंडिंग सम लाइट. दैट लाइट इंटेंसिटी इज गेटिंग रिड्यूस्ड ड्यू टू एब्जॉर्बेंस बाय दिस सैंपल. दिस एब्जॉर्बेंस के साथ एब्जॉर्प्शन एंड दिस एब्जॉर्प्शन इज द बेसिक प्रिंसिपल ऑफ एब्जॉर्प्शन स्पेक्ट्रोमेट्री, है ना? If I would have taken this class, I would have made it more clear to you. But abhi to the exam is knocking at the door, and this is a question answer session. So, are you clear? Are you clear? At least you tell me something. Okay, something you got to know, something you understood. What is absorption? What is emission? दोनों का क्या फंडा है? Yes sir. Yes, clear. Very nice. अब तुम लोगों के लिए एक टास्क है. That would be एमिशन स्पेक्ट्रोस्कोपी और एब्जॉर्प्शन. इसका इंस्ट्रूमेंट्स का नाम बता दो बस. टेल मी द नेम ऑफ द इंस्ट्रूमेंट्स. एमिशन का सबसे बड़ा, सबसे ज्यादा, सबसे पॉपुलर जो एग्जांपल है दैट इज फ्लेम फोटोमीटर, है ना? दिस फ्लेम फोटोमीटर इज आल्सो कॉल्ड FAES. ठीक, flame photometer, and दूसरा whatever the question setter has gave you the question, that is ICPOES, inductively coupled plasma optical emission spectroscopy. All these are written in the old ISSS. Everything is there in the old ISSS, that chapter of analysis of fertilizer, soil and plants. Read that chapter very thoroughly. And absorption का जो सबसे जो important instrument है, that is spectrophotometer, and दूसरा is double S, atomic absorption spectrophotometer. All right. Aishwarya, spectrophotometer is absorption, flame photometer is emission. All right. इसमें गलत नहीं होना चाहिए. All right. Please be very thorough. अच्छे से समझ गए हो, I think. इसका जो अभी instruments है, today only, I would suggest today only go and open that chapter in ISSS and उसको पढ़ लेना, please. है ना? Moving on. In which stage of weathering decomposition of easily weatherable minerals occurs? Yes, Bipin Yadav, it is option C. Yes, you are correct. इसमें और ज़्यादा कुछ बोलने का भी है नहीं. These are very simple questions. No, Nikhila, it is not B. It is not B. This question has also been taken from T.D. Bishwas actually. If you read T.D. Bishwas and S.K. Mukherjee, there you can find the exact line. But here in treatise also, you can find the exact line. In juvenile, weathering just started, but most of the original material can be seen. Whereas virile mein less resistant materials decompose easily and increase the clay content. So decomposition of easily weatherable minerals is decomposition of easily weatherable minerals, that is virile, V. This is also very important question. Please, I cannot stress enough. This is a very, very important question. Please mind this. Please be very thorough with this table. Please be very thorough with this table. This is extremely important. That's why I have taken the picture of the whole table. किसने दिया था, कब दिया था, और this table. All right? Be very thorough. No oxygen is shared in what type of silicate? Spurti is telling A, you are telling nesosilicate. Yes, perfect. Again, I cannot stress enough the importance of this table that is there in old ISSS and new ISSS. जहाँ से तुमको पढ़ना है पढ़ो, जहाँ से रट्टा मारना है मारो. But this table is extremely important. Everything here is important. This formula, this basic formula is very important. नाम तो important है ही. Then these examples are extremely, extremely important. यहाँ से you can definitely expect 2 to 3 questions. With this, you can go a bit easy. You don't have to remember everything, but names and formula and structure, very important. Moving on. Example of sorosilicate. Question directly from the last table. Let's see how thorough you are with the table. What do you think? अरे भाई, killing myself the whole night की जरूरत नहीं है. It is a soil science is a very easy subject. If you see, it is once you understand it, there is nothing much. कुछ जगह तो यार memorize करना पड़ेगा. कर लेना उसको यार, क्या है? No problem. हम लोग करके आए हैं, तुम लोग भी करोगे, बिल्कुल. We are eager to meet you all in IRI. That should be your mentality. That should be your motivation, you know. Examples of sorosilicate, everyone is telling option है, very good. यहाँ पे और कुछ बोलने का है नहीं, because we all know बाकी 3 तो पता ही है, तो elimination से भी हो रहा है. You don't even need to remember the table in this case. The question setter has given the options very nicely. Moving on to question number 21. When is the World Soil Day celebrated? When is the World Soil Day celebrated? Yes, I know all of you know this. इसमें भी कुछ बोलने का नहीं है. इसका जो चीज याद करना है वो याद कर लेना, थीम. एवरी ईयर वर्ल्ड सॉइल डे जो है उसका एक थीम होता है, ठीक है. स्टार्टिंग फ्रॉम 2021 टू 2026, ये सारा जो थीम्स है उसको याद कर लेना. गो एंड फाइंड इट इन गूगल, डेफिनेटली go and find it in Google, and you remember all the names of the themes. These themes are very important. These questions are very frequently asked. What is the theme of World Soil Day of 2025? What is the theme of World Soil Day of 2026? है ना, उसको देख लेना. 2025 का जो है, 2015 का जो है, that is written in the new ISSS. If you see closely, new ISSS का जो cover है उसमें लिखा हुआ है ना. Who is the father of modern soil physics? Modern soil physics? Daniel Hillel only, right? ये कहीं पे कुछ और मिला है क्या? Modern soil physics, I think Daniel Hillel only. He is still alive. Daniel साहब तो अभी भी जिंदा है और उनके किताब के ऊपर तो और कोई किताब नहीं. So probably it will be him only. Moving on. Do you have any trick for nesosilicate? अरे ये सब ट्रिक के चक्कर में मत पड़ो भाई. Nesosilicate is very easy to remember. उसमें ट्रिक का क्या जरूरत है? हाँ, healthy soil for healthy cities. Yes, yes. ये सारा जो themes है, remember those themes. And whoever don't understand Hindi here, I'm telling it for you in English. Please remember all the themes of the World Soil Day. All right, starting from 2021 to 2026. Anything can be asked. Yes, yes, yes. The answer of this is definitely BF3. We all know this. There is nothing new. Exam is just knocking at the door. I don't think it is the correct time to explain these questions. But anyhow, some of the thermalized neutrons, fast neutrons slowed down by repeated collisions enter the detector. The detector consists of a metallic tube containing boron trifluoride gas, BF3, enriched with boron. This is a very known question. I have specifically given you the photograph here so that if you read this PPT, इसको भी थोड़ा पढ़ लेना, इसका understand the principle of this instrument. And this is very nicely written in new ISSS. Old ISSS also it is there. So you can read it from any of the two books and be very important. All these methods of soil moisture estimation, all of them are very important. All right, please read. Upper plastic limit is measured by. These questions are extremely easy. Extremely matlab extremely. इसमें सोचना भी नहीं है. We'll just move on. Richard is the modern physics father. Sir, how much you score in JRF? I gave JRF in 2023. 2023 JRF. My score was 386 and my all India rank was 5. Richard is the father of modern soil physics, you are telling. I don't know about this. You can search and if you get an authentic source, then only you tell. Otherwise, ये जो NTA वाले हैं, ये जो ICR वाले हैं, ये मानते नहीं है यार. They will not. Even if you challenge, pay how much ever money you want, they will not agree until and unless you have an authentic source, either Hillel or ISSS, anything. Without that, without textbook, they will not agree. Okay, so I am getting all the answers. Upper plastic limit is definitely measured by Casagrande apparatus. We all know that. Here I have given you the photograph also. This is also taken from new ISSS. This is also called liquid limit device. So यहाँ पे और बोलने का तो कुछ है नहीं. I think you know the uses of all the other also. Tensiometer is used for measuring what? What potential? Yoder apparatus is for what? And pycnometer is for what? Tell me fast. Tensiometer is used for measurement of soil matrix. We cannot measure soil matrix potential. All right. Yeah. I can understand your. What are you trying to say? What about Yoder apparatus? What do we measure in through Yoder apparatus? Pycnometer for particle density. Perfect. Vipin Yadav, you are perfect. Pycnometer for particle density. What about Yoder? Yoder apparatus से क्या करते हैं यार? What do we do with Yoder apparatus? Wet sieving. Yes, you are correct. We do aggregate analysis. When you will come to your MSc में just घुसने के बाद you will have a course that is called Soil 501, है ना? Soil 501 is soil physics. In that you have to do practical of all of this, है ना? You will have to do practical of all these instruments. Casagrande apparatus, tensiometer, I think all of you have done in UG also. UG में भी वो कराते हैं. Yoder apparatus you will see, and you will have to work. You will have to find the. You will have to do the aggregate size analysis, and pycnometer also you can use for measuring particle density. All right. Moving on. International pipette method is based on. This question is also directly from ISSS. This will test your knowledge. This will test your concept and also how much thorough you are with your reading. All right. International pipette method is based on viscosity, sedimentation, decrease in density, all of the above. Everyone is telling it is option B. Yes, you are definitely correct. It is option B. बाकी जो है decrease in density and viscosity, these are used in hydrometer method, है ना? So here you can clearly see this is also from new ICCS. New ICCS में है. The international pipette method is based on the principle of sedimentation. All right. It is regarded as the standard method, but it is very time consuming, therefore usually not employed where large number of samples are to be analyzed. That is also a very known question. Boykos hydrometer, Archimedes principle. Archimedes principle? You can say, yes, you can say. But it is on the decrease of density, progressive decrease of density with time, है ना? Settle करता है एक-एक करके. So we have come to a problem now. This kind of questions are my favorite and this kind of questions will come. That is the sad part. If you do not like problem type of questions, तो बहुत दिक्कत हो जाएगी क्योंकि ये questions आता है. In my time, I remember they have asked four problems, and in our previous batch, our senior batch, they have asked many. So some problems will be very difficult because there will be no calculator with you in the exam hall. So you have to be very thorough with your quick calculations also, like division. Bulk density के case में you have to divide some weird numbers and you have to get some weird numbers like 1.44, 1.43, 1.49, and the options will be so nearby you cannot eliminate that easily. So you have to practice your division also, and you please be very thorough with this because these are the questions which will decide your rank. क्योंकि जिसको ये आता है they will never make this wrong. They will definitely make this correct and they will get 4 marks. And if you don't know this, so definitely you are behind by -5 or behind by -4. So it will be a huge problem for you. Be very thorough with the problems of bulk density, mass volume relationships. Soil physics से तो भर के problems आता है, tensiometer, everything. So this is a very easy question. Tell me the answer. If the hydraulic conductivity and differential water capacity are, I think you cannot understand the numbers, right? Wait, I'll tell you. It is 10 to the power -5. It is 10 to the power -3. I'm really sorry for this. Value not clear. I have not seen that also. Now you can see 10 to the power -3 is the hydraulic conductivity. 10 to the power -5 is the differential water capacity. Then what will be the soil water diffusivity? यहाँ पे I think values are clear. -8, -8, -2, 2. And you can be very careful with the units. All right, the units are also very important. Spurti is telling D, Aman is telling A, Nikhila is also telling D. Aman is telling A. A तो किसी भी हालत में नहीं है. A तो किसी भी हालत में नहीं है. What is the formula of this? I think you guys know, right? Diffusivity का क्या formula है? Diffusivity means conductivity divided by water capacity. Right? So इतने तो easy तो है. Conductivity is 10 to the power -3. Capacity is 10 to the power -5. Be very clear with the units because units यहाँ पे units भी different दिया हुआ है ना? So the unit of hydraulic conductivity is centimeter per second and the unit of this is centimeter to the power -1. Up 10 to the power -3 minus of -5 और unit हो जाएगा centimeter square per second. So minus of -5 means +5. +5 -3 means 2. 10 square centimeter square per second. All right. Is there any problem? Is there anything that you did not understand here? This is like a very easy, very basic sum that you can get. Nothing is there that is hard. So the answer is 10 square हाँ, ये सब कैलकुलेशन मिस्टेक ही तो नहीं होना चाहिए ना भाई. These calculation mistakes only will cost you your rank. You have to be very accurate on the exam day, you know. Accuracy matters a lot. Accuracy matters a lot because everyone is preparing, everyone will attempt the questions. How accurate you are attempting, that will decide. The following place in India, which is a reserve of phosphorus, जिसने old ISSS पढ़ा है, उसी के लिए ये question है. Nothing is there. This is a very known, very easy, extremely easy question that you can tell, and we can move on. Yes, Purti, if everyone is correct here, we have nothing to say. It is Jamra Kotra, Rajasthan. Old ISSS से लिया गया है. यहाँ पे you can see it is Jamra Kotra in Rajasthan. It has the phosphate rock deposit of 13.5 million tons, which are of high grade. So some keywords are there which you should know. यहाँ से बहुत सारे question आ सकता है. That is कितना tons है, कहाँ पे है, high grade का है, कितना P2O5 रहता है high grade में, and other Indian peers are low grade में कितना रहता है. You can see low grade only 15 to 20, whereas high grade has almost 30. All right, moving on. Critical limit of boron is, इसका एक पूरा टेबल है in soil science treatise, if you can remember. Even if you don't remember, if you are thorough with your new ISSS, this is not at all a hard question. You can tell me the answer very easily. Yes, Purti, already I can see you are writing 0.5. Yes, Aman, you are also correct. Both of you are correct. It is 0.5. So you can see that table in treatise also. It is in there in the treatise. Treatise में एकदम table में एक value दिया हुआ है. But I like this table more because this table is more important. This is from new ISSS. Here you can see the critical limits, you know. Now this question, let's see how well you have read the soil fertility evaluation. All right. In which of the following method of fertility evaluation azotobacter is used for determination of P2O5 and K2O status in soil? This is azotobacter. Azotobacter method कहाँ पे use होता है? Option B, Mehelic aspergillus niger. No. I don't blame you if you don't know this question. It's fine. You might not know. लेकिन यहाँ पे तो लिखा हुआ है ना, Mehelic used aspergillus niger. Then how will azotobacter come here? All the other answers, if you would have told, I would have said fine. But ये तो कभी भी नहीं होगा. This is like the first one you should eliminate. Use your brain also a bit in the exam. Just don't go blindly by. Aspergillus niger is already mentioned here. This will not be the answer. Yes, option C is the correct answer. This I have taken from my UG notes. This is the notes of GKVK, UAS Bangalore. Here you can see azotobacter plaque test. It was given by Sackett and Stewart in 1931. All right. Here azotobacter culture is used and for the measurement of potassium and phosphorus. Azotobacter do special behavior in the deficiency of P, K and Ca. All right. यहाँ पे जो बाकी है, Mehelic aspergillus niger method and Mulder's technique, read about this also. If you don't find it in ISSS, go and read it from Google, no problem. But you should know at least 2 line you should know which organism is used and what are the nutrients that are measured. Organism, you can make a table also. Organism, nutrient, like that. All right, fertility evaluation is very important. You can expect questions. This is very important. The following is used for measurement of radioactivity. Radioisotopes and radioactivity is also very important for JRF, physical science JRF. I must say that. So, tell me the answer for this. Yes, Aishwarya. Yes, Saman, Spurti, Vipin Yadav. Every one of you are correct. It is called GM counter. Can anyone tell me the full form of GM? No, Divya, it is not D. How can it be D? Spectrophotometer se to hum we measure the absorbance, no? Just now I was telling few slides back that is absorption spectrophotometer, that is absorption spectroscopy instrument. However, this Geiger-Müller counter, this is the correct answer. GM counter is a classic electronic instrument used for detecting and measuring ionizing radiation. This you should know. It can only measure ionizing radiation such as alpha particle, beta particle and gamma rays, which is nothing but radioactivity. Geiger-Müller, yes, you are correct. इसका जो मैकेनिज्म है बहुत ही शॉर्ट में एक लाइन में देख लेना. It contains a tube filled with an inert gas at low pressure. When incident radiation passes through the tube, it ionizes the gas, creating a brief electrical pulse that the machine amplifies and counts. उसको बोलता है avalanche of electrons. जब एक ionizing radiation जाता है, it ionizes a gas molecule. वहां से एक इलेक्ट्रॉन निकलता है. एक ऐसा इलेक्ट्रॉन निकल के सबको धक्का मारते 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 it makes a flood of electrons. It is called avalanche of electrons. And then वो एवलांच ऑफ इलेक्ट्रॉन जाके बीच में कैथोड रहता है एंड आउटसाइड में एक एनोड रहता है. ये एनोड में जाके हिट करता है एंड करंट पल्स इज जनरेटेड, जिससे हमें पता चलता है कि व्हाट इज द रेडिएशन. सो इफ इट इज गिविंग हाई रीडिंग मींस हाई रेडिएशन. So there is one catch. GM counter can tell you whether it is high radiation or low radiation, but it cannot tell you what is the type of the radiation. It cannot tell you whether it is alpha, whether it is beta, whether it is gamma. That it cannot tell. Lekin it can tell कि कितना ज्यादा है, how much is the radiation happening there, or how low is the radiation. All right. Moving on, the charge of beta particle is. This question, if anyone answers correctly, I will be extremely impressed. वेस्ट बंगाल डोमिनेट्स इन सॉइल साइंस. हाँ यार पूछो मत. स्टेट कोटा है ना उसके लिए. 40% से ज्यादा तो आने नहीं देता है. इवन विथ AIR 5 I could not get in IRI because of state quota, you know. Aishwarya is telling option B. Spurti is telling option C. All right. Well, both of you are correct. The charge of beta particle can be both positive and it can be both negative. All right. So if you study deeply and thoroughly, you will know that beta particle can have a charge of both -1 or +1 depending on the specific type of decay taking place. दो टाइप का radioactive decay होता है. One is called beta minus, one is called beta plus. Beta minus decay and beta plus decay. Harshvardhan Dhakad, it is totally wrong. It cannot be no charge. It will be both. So this beta minus is the most common. So हमारा जो question setter है वो ये समझ के बनाया था the most common. So in exam you cannot mark two answers, right? If both is there, you can mark both. If both is not there, in that case you can mark negative because it is most common. है ना? This is the most common type of beta particle and is essentially a high energy, high speed electron ejected from the nucleus. It carries a relative electrical charge of -1. Whereas beta plus particle, also known as a positron, this is the antimatter counterpart to an electron and it carries a relative electrical charge of +1. So in the marathon series or in next classes, probably in the marathon, if I take radioactivity, I will make you understand what is beta plus decay, what is beta minus decay. अभी उसका जरूरत नहीं है. But remember, it can be both, but more appropriate answer would be negative if it is asked in the exam. All right. Moving on. The acidity having the lowest magnitude is. These are all first year level questions, man. Please do not waste much time here. Tell it fast and we will move on fast. I can see option D, option D, option D. Yes, all of you are correct. Here we directly we have taken from old ISSS. Here you can see what are the types of acidity. Everyone, all of us know that. But the concentration of hydrogen ion in soil solution due to active acidity is very small, है ना? Implying that only a meager amount of lime would be required to neutralize active acidity. In spite of smaller concentration, active acidity is important since the plant root and the microbes around the rhizosphere are influenced by it. All right. This is also a straight question from treatise. If you are thorough with your reading, this is nothing. You can simply tell the answer. club root of cabbage in cold crops decreases by liming, alkaline soil reclamation, over liming, all. इसका आंसर क्या होगा? दो जो डिजीज है वो तो याद रहना चाहिए, एक है क्लब रूट और एक है स्कैब. ये दोनों है opposite disease. These two are opposite disease, club root and scab. One happens in one type of soil, one happens in other type of soil. Yes, all of you are correct. It will be liming. Liming से decrease होगा मतलब in acidic soil, acid soil में there is a chance of club root. Acid soil has the susceptibility to club root. Similarly, higher pH soil, यानी कि sodic soil or salt affected soil, they are prone to scab. So I specifically remember for my 2024 SRF, the SRF which was before my senior batch, there they have given a statement that liming of soil decreases the incidence of scab in potato. True or false? What would be the answer? Liming of soil decreases the incidence of scab. True or false? कैसे true है यार? I'm telling you. False. It is false. It is false. Scab happens in higher pH, whereas club root happens in lower pH. ठीक है, तो लाइमिंग करोगे pH बढ़ेगा, क्लब रूट घटेगा, लेकिन इसका लाइमिंग करोगे इसका pH और बढ़ेगा, this will be more, no? So scab will increase. This is from treatise, है ना? This is very important. Itai disease is caused due to excess of Itai disease is caused due to the excess of option C, option C, option C. There is nothing to know. Here I have given you a photo of how it looks and how it enters. It enters into the rice. ये rice अगर खाया for longer period, it becomes itai. Also it is called ouch. Yes, you are correct. यहाँ पे बाकी जो है, बाकी options are also not worthy here. If the options had mercury, chromium and all, फिर थोड़ा मजा आता. इसमें तो मजा नहीं आया. What is the bowl unit for K2O? This is also a very sitter question. If you have read ISSS, this is a 1 second question. What is taking you so long to answer this? What is the bowl unit for K2O? Yes, it is 76. इसमें इतना सोचने वाली क्या बात है? बाउले यूनिट का जो कॉन्सेप्ट है वो मैं यहाँ पे तुम लोगों के लिए दे दिया हूँ. If you read the PDF, you will get to read that. So it was expanded upon law of diminishing returns. Single Boule unit is defined as the exact amount of a specific fertilizer nutrient required to produce 50% of the maximum possible crop yield. है ना? Assuming all other growth factors are fully adequate. So these are the standard values that are established. Actually ये जो values है इसका unit भी याद रखना. Units are very important. The units are pounds per acre. उसको अगर kg per hectare में दे दिया so you have to convert. If it is asked in kg per hectare, you have to convert. These values are given in pounds per acre. These values are given in pounds per acre. If it is asked in kg per hectare, you have to convert. And these values are for P2O5 and K2O. If it is asked for specifically for K and P, then you also have to convert. You remember those values, right? 1.20 and 2.29. The factors for conversion. 5 tip related to deficiency of following element. Be very thorough with your reading, all right? Be very thorough with your reading and there will be no problem. You can definitely answer all the questions. All of you are definitely correct. This I have taken from treatise, soil fertility. Here you can clearly see copper. What are the functions of copper? This is also very important. That's why I have taken this part especially. This part has been taken to let you know that this is very important and you have to read the functions and also the deficiency symptoms. Here you can see white tip. All right, moving on. So this is a very interesting question. I personally like it very much. I like nitrogen so much. So what is the assimilation of N2 to NH3? It requires how much ATP? How many ATP? Sorry. How many ATP is required for conversion of nitrogen dinitrogen to ammonia? Yes, Harshvardhan, it is, of course, it is 16. Here, this is the reaction that has been taken from old ISSS. So you have to, what all you have to remember here? यहाँ पे only through this equation you have to remember lots of things. All right, I will tell you everything. Number of electrons. This has also been asked. This is question number 1. Number of ATP. This is question number 2. Number of hydrogen ions. This is question number 3. Number of moles of ammonia produced. This is question number 4. All right. So from this simple equation, 4 questions can be asked. Number of ATP, number of electrons, number of hydrogen ions, and moles of ammonia formed. In my MSc first semester exam, our microbiology teacher has asked for 1 mole NH3 formation, what would be the number of electron and what would be the number of ATP. All right. So it is nothing. All these numbers will be divided by half. Because यहाँ पे अगर देखोगे तो this is for 2 moles. This is for 2 moles. So if they are asking for 1 mole, you have to divide all these numbers by half. 16 will be 8 and 8 will be 4. All right. Be very careful. ऐसे ही बस देख के आ रहे ये तो मुझे पता है बोल के जाके मार मत देना. Then you will not only get -1, you will get -5. ये ध्यान में रख के चलना. Because if you miss this kind of questions, then your rank is also gone. So be very patient, be very careful, read very thoroughly all the options, all the question, and then you should mark. All right. Nitrification bacteria is obligate heterotroph, obligate autotroph, facultative autotroph, facultative autotroph. Harshvardhan is saying B. Aman is saying B. Shomik is saying C. No, you cannot say it is C. It is wrong. Shomik, it is wrong. Go and read it very carefully. This I have taken from old ISSS. Obligate autotrophic aerobes. Obligate autotrophic aerobes. दोनों में कोई compromise नहीं है. दोनों में कोई compromise नहीं है. It is obligate aerobes. अगर aerobic condition नहीं है तो नहीं होगा. अगर autotrophic मतलब autotrophic भी it is obligate. There is no compromise. कुछ facultative का कोई scene नहीं है. All right. So this is very important. Be very thorough with the nitrogen chapter of the old ISSS. That is very good, you know, very good. Written by Dr. S.R. Mohanty from ICAR CRRI. He was from our institute, principal scientist. You read that chapter, that is very nice. Strictly anaerobic bacterium. This is also BSc first year question. There is nothing to discuss here. Yes, Purti, you are absolutely correct. Harshvardhan, Clostridium. Yes, this is Clostridium. All of us know that. And this box is extremely important. This box I have discussed in previous class also. And again, sir, how many marks are required to get college for open and OBC? How many? College तो यार कितना भी marks में मिल जाएगा. Any marks you get more than 250, you will get any college. Any college तो is not your target. No, your target should be IRI. And IRI आने के लिए open category में you should need 380, 390 plus. That too, you have to see the state quota and all. Like if you have no one from your state before you. Top colleges IRI के लिए तो 380 plus for general category. That also you have to make sure that there is no one from your state before you because 40% state quota is there. और OBC के लिए मान लो 350 for IRI I can tell. BHU and all के लिए थोड़ा 10-20 नंबर घटा लेना उसका. All this analysis and all we will do once the exam is over. पहले exam तो होने दो, exam का level के ऊपर depend करता है. Like in our time it was 386. Our seniors time the question was easy, it was 406. Our next time the question was difficult, it was 370. So you cannot tell a number, right? वो पहले exam होने दो, then we will analyze and then we can tell you. So here What I was telling, this box is extremely important. यहाँ से बहुत सारे क्वेश्चन आते हैं. Azotobacter is a question, Thiobacillus is a question, Klebsiella is a very important question. याद रखना Klebsiella, since it is facultative anaerobe, ये बहुत ज्यादा पूछा जाता है. I have seen at least 3-4 times. Clostridium, तो यहाँ पे क्वेश्चन में है. It is very important. And also this is also very important. ये बॉक्स exactly ऐसा ही memorize होना चाहिए. You should memorize this box definitely. All right, very important. Moving on. In determination of organic carbon, oxidizing of organic matter is done by this set is like refreshing your memory, you know. You will see less statement question, less asserts and reason. So this is just refreshing your memory, how thorough you are, how good you are reading. Spurti is saying C. Aman Kumar, you are saying A. That is totally wrong. Organic carbon के साथ KMNO4 का क्या मतलब है? Totally wrong. Yes, all of you are correct. किसी के मन में आ सकता है कि क्रोमिक एसिड कहाँ से आया? हमने तो K2Cr2O7 पढ़ के आया है. K2Cr2O7 का नाम ही क्या क्रोमिक एसिड है? बिल्कुल नहीं. K2Cr2O7 का क्या नाम है भाई? What is the name of K2Cr2O7? It is potassium. कोई नहीं, तुम लोगों को लिखने में टाइम लगेगा. It is potassium dichromate. So we put potassium dichromate. यहाँ पे ऑप्शन में बोल रहा है क्रोमिक एसिड. How is that possible? That is definitely possible because chromic acid is called the active oxidizer. The reaction, if you remember, very good. Potassium dichromate, yes, you are correct. If you remember, potassium dichromate के साथ साथ हम लोग H2SO4 भी डालते हैं, right? This H2SO4 does the digestion actually, and this K2Cr2O7 is the oxidizing agent. So the reaction between dichromate and the sulfuric acid, इन दोनों का reaction creates chromic acid. And chromic acid का अगर formula पूछे, that is also very important. H2CrO4. Remember this, which is the actual potent oxidizing agent that attacks the organic carbon. All right. Sir, how can I get this class PDF? You can definitely get this class PDF. वो channel में in this video description and in the channel description there is one Google form. You have to fill that Google form and instantly you will get that PDF. You can get this class PDF with all these explanations and all these notations. Moving on to question number 40. We are running very late. We have used huge amount of time, so जल्दी हम इसको करेंगे और निकलेंगे. I am very excited for the marathon. I hope you guys are also excited. The revision is going to be very good. It will be starting soon. Yes, Harshvardhan is saying it is reducing. बाकी और कुछ आंसर? Catalyst, Spurti, totally wrong. Not at all. It is a catalyst. कुछ catalyst की बात है ही नहीं. It is extremely wrong answer. No catalyst. Yes, we have got two answers, so we will move on. It is the reducing agent. अब इसका क्या मतलब है उसका भी explanation मैं आप लोगों के लिए लेके आया हूँ. The role of stannous chloride SnCl2 acts as a powerful reducing agent. क्या करता है SnCl2? Reducing agent का क्या जरूरत है? Everything we already know, because when I was telling you about that spectrophotometer, in that I told the development of color is necessary, otherwise it cannot detect, right? इसीलिए हम क्या करते हैं, if it is a colorless solution, तो उस colorless solution में we will add some reagent or some chemical that will react with that solution. Not only that solution, the element of interest, suppose हमें phosphorus से interest है, phosphorus कितना है उसको निकालना है, तो हम उसमें ऐसा कुछ reagent डालेंगे जो phosphorus के साथ react करेगा और उसमें फिर ऐसा कुछ डालेंगे जो color develop करेगा. So हमारा मकसद, like our aim is that color development should be proportional to the amount of phosphorus that is present in the sample, because then only this spectrophotometer serves its purpose. So you remember, if the sample is colorless, we have to supply such a reagent that will form complex with the element of interest, and the color development will be proportional to the amount of element that is present in the sample. All right. तो phosphorus में क्या करते हैं हमें सब पता है. We make a phosphomolybdate complex. जो पहला reagent है reagent A, reagent B. We add ammonium molybdate जिसके वजह से phosphomolybdate complex होता है. Then that phosphomolybdate complex is reduced by SnCl2 एंड अभी के लैब में एसेंशियल टू उतना ज्यादा यूज नहीं होता है. इफ यू डू इट बाय योर ओन हैंड, यू नो इट इज कॉल्ड एस्कॉर्बिक एसिड. एस्कॉर्बिक एसिड से भी हम रिड्यूस करते हैं. So it donates electron to the phosphomolybdate complex, reducing MO6 plus to a lower and mixed oxidation state. This structural reduction triggers a massive shift and turning the solution as intense brilliant blue known as molybdenum blue. So that blue color occurs. जिसका हम measurement करते हैं. If you have done phosphorus measurement, you will know. Otherwise, you will have to do it to know. There is a intense blue that is called brilliant blue, and also it is also called molybdenum blue. तो ये ब्लू कलर का क्या जरूरत है? बिकॉज इफ दिस ब्लू कलर, दिस इंटेंस कलर इज नॉट देयर, द स्पेक्ट्रोफोटोमीटर कैनॉट डिटेक्ट. स्पेक्ट्रोफोटोमीटर में इट विल ओनली वर्क व्हेन देयर इज अ कलर्ड सॉल्यूशन, बिकॉज दैट कलर विल ओनली एब्सॉर्ब. हम यहां से जो स्पेसिफिक वेवलेंथ के लाइट को छोड़ रहे हैं उसको एब्सॉर्ब करने के लिए वी नीड अ कलर. सो फॉर द डेवलपमेंट ऑफ कलर वी आर डूइंग सो मेनी थिंग्स. फर्स्ट वी आर एडिंग दिस अमोनियम मोलिब्डेट, उसके बाद उसको रिड्यूस कर रहे हैं टू मेक अ कलर, राइट? So according to Beer's law, which I made you understand some slides back in detail, according to Beer's law, this intensity of this blue color is directly proportional to the amount of phosphorus that was originally in the soil extract. So यही तुमको बताएगा, इस blue color का intensity तुमको बताएगा कि how much phosphorus was present on the sample. यहाँ पे I have added you a very important note also for you. If you read this PDF, you will get to know. SnCl2 is classic and highly sensitive reducing agent, but its major drawback is the blue color it produces is unstable and fades very quickly. Therefore, nowadays in modern labs, ascorbic acid is used. So this is also a question. यहाँ पे SnCl2 के जगह में अगर ascorbic acid रहता, दोनों का same use है, that is reducing agent. Did all of you understand? Please tell me एक बार comment में लिख दो. Otherwise, I will feel like I just told so many things for nothing. Please write anything in the comments so that I know you understood something at least. All right, you are very keen in answering the question, it seems. पिछला स्लाइड में जो समझाया वो तुम लोगों को समझ में आया? Why it is a reducing agent? Especially Spurti, did you understand? You were writing it as a catalyst. Did you understand why it is a reducing agent and why is it needed? All right, very good. हाँ, इसमें तो यार क्या, इसमें टाइम कुछ बर्बाद नहीं करना है. This is the logo. I think you have all seen this in the ticket of IRCTC. IRCTC के टिकट में भी ये आता था, International Year of Millets 2023. बाकी जो 3 ऑप्शन है इसका भी ईयर्स याद कर लेना. All right, please remember the years of these also and be very thorough with the current years like 25, 26, 27, है ना? Be very thorough with the current years. Chemical used in cold cloud seeding. Again a meteorology question, I think, which is very easy for you. It is a bit tough for me because I have read meteorology long back in 2023. Yes. Yes, you are correct. International Year of Soil Health नहीं, International Year of Soils was 2015. ये इसका जो न्यू ISSS है उसके कवर में लिखा हुआ है इंटरनेशनल ईयर ऑफ सॉइल्स. इफ यू सी इट इज 2015. हाँ, आई एम गेटिंग आंसर्स बी. इसका आंसर बी है क्या? इसका आंसर बी है क्या? Actually, I also know it is AgI, right? It is silver iodide. अब silver iodide का all of you are telling B, AgCl2. I have checked it in 2-3 places और मुझे तो KI मिला, but I am not sure with this question since I cannot say you for sure, you know. So please check this. I am not sure, but ये मुझे जहाँ से मिला, I have taken it from a ऐसे ही normal internet से लिया. So here the cold cloud, they are telling that silver iodide is the standard. Silver iodide, I definitely know. But whenever this Cl minus ion is there, I have seen it for majorly for warm cloud seeding only. So when it is cold, it is telling that silver iodide is the global standard, but it can be substituted with potassium in many agricultural weather modification programs like AGI. Ki also provides an excellent crystal matrix that induces the supercooled clouds. But since I am not sure with this, I will not say it for sure. Please check it once. I will also check it. For meteorology, the standard books are S.R. Reddy, Principles of Agronomy. I have read it from there only. So in there, I have seen only AGI. So this AgCl2 and Ki, I'm not sure, but I think it is Ki because I have got this from a good source only, very good source. You can check it in, if you have Gemini or ChatGPT Pro, there also you can check it. Anyhow, this is a bit doubtful question, but since I am not sure, I will not give you the wrong answer. I do not know this for certain. So please go and please check this. Cold cloud seeding ke jo chemicals hai and warm cloud seeding ke jo chemicals hai, whatever the chemicals are used for both of this, make a chart, make a table, and remember this because this is a very important question. All right. This one I am sure. Let's see if you are also sure with this. What is the medium range weather forecast? Is it up to 3 days? Is it up to 3 to 10, 10 to 30, greater than 30? What is the range for medium weather forecasting? Option B, 3 to 10, 3 to 10. Yes, this is very easy. Medium range. Here I have given the definition of all the three. You can see short range is up to 3 days, less than 3. Medium range is 3 to 10, and long range is more than 10 days to a whole season also. यहाँ पे एक क्वेश्चन आता है कि which one is most important for farmers, है ना? So most important for farmers, that is also a controversial question because short range is also used by farmers for immediate day-to-day operational decision. जैसे उनको पता चलता है पेपर में, जैसे न्यूज़पेपर में आता है कि कल बारिश होगा, so they will stop spraying and all. But this medium range forecasting is also very important for farmers because this is the most critical window for strategic farm planning. You can see. So I think I have seen the answer key as medium range only for farmers, but short range is also very important. So use your mind and tick the correct answer. If all three are there, I think medium range is the most important and second most important in short range. So in the medium range, the agronomic uses medium-term logistics such as scheduling heavy machinery operation, hiring laborers, sowing, harvesting and everything. And this short range can be only used for कि कल spray करूँ कि नहीं, कल herbicide डालूँ कि नहीं, like that. And long range तो long range will decide the crop selection, long range will decide कितने से कितना crop window होगा, how long it will take and everything. So long range is not that important for farmers. For comparing two means when sample size is small, I will make it more easier for you. When sample size is less than 30, then which test is used? This is also a very basic statistics question. Statistics important hai bhai. Statistics se 2, 3, 1, 2 question it might come. So be very thorough. है ना? Statistics is very important. It will go on with your life till your PhD, till your everything. So yes, you are telling it is T-test. There is, I am very sad that there is no time to make you understand all these tests. But कोई बात नहीं, बाद में कभी मौका मिलेगा तो we will tell. But here, for your betterment, I have given small definition for all of this, है ना? For all of this, please, if you get this PDF, please read from here that this T-test se question आता है, who developed that? William Gossett. And this test is also called student's T-test because the student was the pen name of Gossett. Gossett used to write his articles in the pen name of student. That is why it is also called student's T-test. It is conventionally n less than 30 and the true population standard deviation is unknown. All right. Z-test is very similar, exactly similar to T-test, but when n is greater than or equal to 30. All right. And F-test is nothing but a ratio. It is a ratio. It is used to compare two variances. It is used in ANOVA. If you have done ANOVA table, I think all of you have done ANOVA table in your stat class. There you can see, last में जाके हम एक column बनाते थे, that is FCAL. फिर उस f cal के साथ f tab को हम कंपेयर करते थे. If it is greater, then null hypothesis is void. All right. How many questions comes from statistic? ये तो सिर्फ क्वेश्चन सेटर ही बता सकता है. How can I tell you how many questions will come this time? Generally it is 2, कभी 3, कभी 4, might be 5. So, but stat is very important. And also here chi-square test also I think all of you have done. If you have done your genetics classes well, in genetics they teach you chi-square test, where it is used for categorical data and it is a non-parametric test. It is a non-parametric test. अब ये क्या है, parametric क्या है, non-parametric क्या है, all this I cannot tell you now. Definitely the time is very short. You can, once you come in your MSc, you will read it for yourself only. But you should be thorough. At least इतना तो पता होना ही चाहिए about everything. If not, जाके अपना stat का note खोलना और पढ़ लेना एक बार, है ना? Moving on. Again, a very seater and very easy question. There will be no time wasted for this. 15 minutes hai, 15 questions hai. Let's see if we can complete 15 minutes in 15 questions. Yes, option A is correct answer. I have taken this from treatise. Father of soil taxonomy is Guide is Smith. You have to be very thorough with your treatise. बाकी यहाँ पे जो मार्बुट है, इनका भी लिख देता हूँ. Marbut is nothing but he given the concept of pedocal and pedalfar, which is also called the morphogenetic system of soil classification, है ना? Then मिलने के साथ क्या है? मिलने given the term catena 1935 and Dokuchev is father of soil science around 1900s में Dokuchev was there. How many questions come approximately? I told you, no? You can expect 1 से लेके 5 तक, in the range of 1 to 5. Okay, इस क्वेश्चन में बाकी ऑप्शंस भी क्लियर है. कैटेना कौन दिया था? फादर ऑफ सॉइल साइंस. एंड डोकुचेव ने और बहुत सारे टर्म भी दिए थे, लाइक बायोजियोकोनियोसिस. इफ यू रिमेंबर, if you have read the soil biology from the new ISSS, then you will know biogeoconiosis term was given by Dokuchev. So Dokuchev तो हर बार आता है. The genetic system, zonal, azonal, intrazonal, everything. Dokuchev is revolving around everything of soil science. Moving on. Regur soils are also known as, this is also a first year level question. No time to waste. Tell me fast. I can see all option is yes, yes, yes. It is very easy. This I have taken from new ISSS, from the chapter Soil Genesis and Classification, written by Dr. S.K. Singh. That chapter is also very important. You should be very thorough with that. So here you can see this is very important. इसको याद रखना. I have specifically taken this whole screenshot only for you people, क्योंकि इसको याद रखना है. This is very important. इसको याद रखना है, CEC याद रखना है, and pH याद रखना है. And then definitely कहाँ पे मिलता है वो याद रखना है, and ये तो याद रखना ही है. All right. And also this I think all of you know, याद रखने का कुछ जरूरत नहीं है. This is also very important, how this black color comes. So all these points are extremely important. So जिनके पास new ISSS है, वो लोग new ISSS से इसको पढ़ लेना. Definitely you should read this, preferably 1 or 2 days before exam, because this is very important. उसको देख लेना. अगर new ISSS नहीं है तो treatise से पढ़ के जाना. All these points are exam worthy points. All these points, from each and every line there can be questions. From this line also there can be question. Each and every line is question worthy here. So be very thorough. Soil classification followed in India is, this is also a very seater question. इसमें कुछ नहीं है. Yes, Purti, you are correct. The USDA soil taxonomy system that has been used by us. बाकी USSR का तो there is no soil classification system. ISSS का भी there is no soil classification system. Like even if we consider it as International Union, International Society of Soil Science, still soil classification, so it was only USDA only, the major system. So there is nothing to know. But here I have given you the explanation. इसको तुम पढ़ सकते हो if you get the PPT. And here you can see the facts also. 1969 में ICAR took it through NBSS LUP. They officially adopted the USDA soil taxonomy. और इसका जो 12 order है, that is also very important. Black soil rich in humus, true or false? Mainly it is true because black soil organic matter also ज़्यादा ही होता है majorly. This question is also straight from new ICCS. Tell me the answer. Soil health card. 1 year. 1 year is extremely wrong, Aman Kumar. That is totally wrong. Yes, everyone is correct. Nikhila, Spurti, Harshvardhan, it is correct. Of course, it is 3 years. You have to be very thorough with your textbooks. All right, old ICCS and new ICCS, ekdam, it should be on the tip of your tongue and it should be on the tip of your fingers. This is directly taken from new ICCS. Here it is clearly it is written at an interval of 3 years. No question is coming from outside. Everything is there in your books only. It is in front of your eyes. You just have to read. This part is so well written. If you read this, only one reading will be enough. This is so well written and so well explained. Only one reading will be enough. क्या properties है? What are the properties that are measured? What are the parameters that are measured in a soil health card? उसमें क्या information मिलता है? कितने दिन में renew होता है? कितना इसका sampling size है? कितना grid का size होता है? कितना what is the field size? बस. Only 5-6 questions only. But if you read this only once, it is very easy to remember. There is nothing. Be very thorough with your textbooks. That only will give you the ranks. Fulvic acid exceed humic acid in. This is also very easy question. Black soil respond well with irrigation. नहीं भाई कैसे करेगा? Black soil has high water holding capacity, no, and high moisture. So उनके जिसके पास already जो चीज है वो respond नहीं करता. If you already have huge amount of money, if I give you 10 rupees, you don't care, you don't respond. But someone with no food and no money, even if I give 5 rupees, that person will be delighted. That is called a response. Fulvic acid exceed humic acid in. Aishwarya and Harshvardhan are telling oxygen. Yes, all of you are definitely correct. This is from old ICCS, Soil Organic Matter, written by Dr. Kunal Kumar Ghosh. He is a legend in the field of soil organic matter, Dr. Kunal Ghosh. So there you can see the elemental composition I have brought for you. Here you can see C ज़्यादा है HN, whereas O इधर ज़्यादा है ना? So oxygen is clearly more in fulvic acid. What is enthalpy? Another question from basic chemistry, class 11-12 NCERT. NCERT, even if you are from state board, that's also not a problem. Any board has this. This is the basic thermodynamics. Spurti, how can you be so wrong? Read the question. Enthalpy and entropy are different. This is entropy. This is entropy. Do not get confused. इतनी जल्दी नहीं है. You can take your time. You can read the question and then you can answer. Change of heat और liberation of heat में तो कुछ बोलना नहीं है. जहाँ से heat निकल रहा है, that is liberation of heat. Change of heat is change in कितना heat इधर गया उधर गया, that is del U. And this total heat of the system is called enthalpy. In thermodynamics, enthalpy is a state function. इसको भी याद रखना है. It is a state function that represents the total heat content, right? And it is mathematically defined as H equal to U plus PV, whereas U is internal energy and P is nothing but product of pressure and volume. All right. We cannot measure directly the H. ऐसे direct H measure करने का कोई instrument नहीं है. We cannot measure the total heat of the system. So we measure delta H. यानी कि change in heat we can measure. We cannot measure the total heat. Absolute value को हम measure नहीं कर सकते. 50 था, अभी 30 हुआ. So this 20 can be measured, but this 50 and 30 अलग से it cannot be measured. We cannot measure differently this 50 and 30, but we can measure this 50 minus 30 equal to 20. Partial pressure of carbon dioxide in submerged soil declines rapidly when soil is rich in. This is also a very conceptual question. I would be very impressed if you can answer this. Let's see. PCO2 in submerged soil declines rapidly when soil is rich in organic matter, silicate ion, Fe and Mn, all. This is a very, very brilliant concept. And if you can answer this, definitely I will be very impressed. Aman is telling A. No, Aman, you are wrong. Nikhila and Harshvardhan is telling Fe and Mn. Yes, you are correct. It is Fe and Mn. अब ये क्यों होता है उसको थोड़ा समझ लेते हैं. No, it is not silicate ions. It is not option B. It is not at all option B. It is option C. अच्छे से ध्यान से सुनना, समझ में आ जाएगा. There is nothing rocket science, but please be careful. Please be attentive. See, the initial CO2 peak when a soil is submerged. When a soil is submerged, gas exchange with the atmosphere is drastically cut off. तो जो gas exchange हो रहा था, that is cut off. Now this oxygen is rapidly depleted. Whatever oxygen was there, it is rapidly depleted because oxygen का renewal नहीं हो रहा है. यहाँ पे जो anaerobic microorganisms है, they started functioning, and these anaerobic microorganisms begin to decompose the native soil organic matter and any added residues. This intense anaerobic respiration generates large quantities of CO2. This intense anaerobic respiration generates large quantity of CO2, causing the PCO2 in the soil solution to rise, typically reaching a peak within 1 to 3 weeks of flooding. इसमें किसी को कोई समस्या नहीं है. हमने इसमें पानी दिया. This process gets hampered. So whatever oxygen was there, that is getting used up by the microbes, and the CO2 is so high, the partial pressure of CO2 gets a peak. Then what happens? As the soil becomes progressively more anaerobic, the redox potential drops. We all know, जब oxygen का supply नहीं है, तो जो the redox potential है, that begins to go down. So now the redox potential is going down. This redox potential is going down, triggering a sequential reduction of alternative electron acceptors. If you remember the series in the submerged soil, this was the series, right? इसको याद रखना है with all the values of the volts and everything. You have to remember very thoroughly. So with the EH जितना नीचे जा रहा है, this Mn and Fe becomes active. See, Mn4 plus is reduced to the highly soluble Mn2 plus. Fe3 plus is reduced to the highly soluble Fe2 plus. अब क्या हो रहा है? Soils rich in iron and manganese, this reduction process dumps massive concentration of divalent cations into the soil solution. These newly generated cations readily react with the dissolved CO2 present as carbonic acid to precipitate out as highly stable insoluble carbonate, specifically siderite यानी कि FeCO3 and rhodochrosite, that is MnCO3. So this Fe and Mn, they will start to scavenge. They will start scavenging the CO2 and form siderite and rhodochrosite. This CO2 is actively absorbed and getting precipitated. That is why this PCO2 in submerged soil declines. That's why zyada Fe and Mn agar hai, तो it will reduce. Did you understand? Did you understand? Please tell me in the comment, समझ में आया कि नहीं, या कहाँ पे समस्या हुआ? If there is any doubt, some place you did not understand, you can tell. Right? Very good. Increase in zeta potential of soil particle leads to, this is again a BSc second year level, you can say. Second year mein they read soil chemistry. So what is the answer? Yes, it is definitely option C. इसमें तो कुछ बोलना नहीं है, nothing. Soil science students definitely knows it is deflocculation. Zeta potential बढ़ता है, तो repulsion बढ़ता है. The two particles will go both sides and there will be deflocculation. All right. Anion responsible for soil aggregation is, this is also a very easy question. We read it in agronomy, we read it in general agriculture, we read it in everything. What are the anions responsible for soil aggregation? Anion responsible for soil aggregation is B. No, it is not B, not at all B. No, it is not sulfate. How can it aggregate the soil? Sulfate is highly mobile. Sulfate तो लीचिंग होकर नीचे चला जाता है ना. Sulfate and nitrate तो no chance. Nitrate and sulfate no, because these are highly mobile in the soil solution and they are leached down. So the answer would be phosphate. This you all know, right? Application of phosphatic fertilizer improves the soil structure. This we have read from long back, from our BSc days only we have read it. Application of phosphatic fertilizer improves the soil structure. How? The phosphate bridging mechanism. It is called the phosphate bridging mechanism. It binds to the oxides and clays. Phosphate ions readily react with the broken edges of clay minerals. You know the concept of ligand exchange. Definitely, it is ligand exchange. It is also called the chemical stapler because phosphate is polyvalent. So one part can chemically bind to a clay, another part binds to a cation, which is in turn bound to soil organic matter, so it can aggregate. And also, this creates a rigid, highly stable macromolecular bridge. Clay, metal, phosphate, organic matter, everything is bind together and it helps in aggregation. This is a, see as it fixed in soil. Yes, yes. Here I have given the reason, all the reasons I have listed here. Phosphorus ligand exchange होके soil के साथ रहता है. It is not mobile. It will not leach down. It will stay there. And since it is polyvalent, तो ligand exchange होने के बाद भी it has the scope of binding to other oxides and clays and other metals also. So जितना ज़्यादा binding होगा organic matter के साथ, metal के साथ, oxide के साथ, it will aggregate. Definitely, it will aggregate. Nitrate or sulfate तो no chance, no. Molybdate at some, in some case it is similar to phosphate, but since it is very low, the answer will be phosphate only. And this question you guys know, right? कि phosphatic fertilizer improves the soil structure. इसमें क्यों इतना problem हो रहा है? PF scale was given by, we have already discussed this. We have already discussed this in today's session only. So tell me, PF scale was given by who and when? You have to tell me the year, है ना? Option D, Nikhila. Yes, we will not waste time here. It is of course option D. Here again, I have given the same PPT. It is 1935, given by Schofield, the PF scale. Here, Sorensen, Atterberg gave Atterberg limits. Swedish scientist Atterberg gave Atterberg limits in 1911. And Sorensen gave pH. Yes, Shomik, you are correct. Sorensen gave the concept of pH in 1909. You should remember the years also. JRF में years भी आते हैं, important है. So pH 1909, Atterberg limit 1911, and 1935 is Schofield. Father of field plot technique. Again BSc first year. We are very frequently going to BSc first year and coming back to fourth year JRF. Option B. Yes, इसमें तो कुछ नहीं है भाई. It is definitely, it is option B. Jean-Baptiste Boussingault, a French guy. He was the father of field plot technique. In the 1830s, the French chemist Jean-Baptiste Boussingault established the first true agricultural experimentation station in France. So, इसको देख लेना. This is nothing but this is a very easy general agriculture question. Here, DJ Nicholas gave the term. Right now, functional. Glauber, as far as I remember, this is also there in RS Mina. This Glauber, he gave the definition of something, plant gets its nutrition solely from water or something. Dekh lena, all these names are important, all right? Please be very thorough. Winter solstice is on. कब है winter solstice? बताइए. Winter solstice कब है? 23 Sep, 21 Jan, 21 Dis, 17 Dis. When is the winter solstice you are telling? 21 Jan. Or are these the old comments? Achha, these are old. See, A. No, it is not 26 September, Shomik. Shomik. Not at all. Yes, it is C. This is very known phenomenon, right? This is class 7, class 8 geography only. December 21 is winter solstice. That is the longest night and the shortest day in the northern hemisphere. March 2021 is the vernal equinox, that is day and night is equal. September is the autumnal equinox, September 23, that is day and night equal. And June 21 is summer solstice, that is longest day and the shortest night. This is just normal geography. इसमें तो कुछ सोचना नहीं है भाई. This is extremely easy and extremely sitter question. And it is a exam worthy question. It can come anytime. ऐसे questions को बिल्कुल नहीं गलत करना है, बिल्कुल नहीं. You have to be very thorough. Winter solstice, vernal equinox, autumnal equinox, and summer solstice. Indian Institute of Tropical Meteorology is located at. इसमें भी कुछ बोलना नहीं है. You just tell the answer and we will move on. Shomik, please be very thorough with this. These are very easy questions which require your attention, and it's like you cannot just miss these questions. Tell me, anyone? No one knows where the Indian Institute of Tropical Meteorology is located? Arey yaar, I expected the answer from you. It is in Pune. This question is also important. Agrometeorology is there in the syllabus, no? So it will be Pune. All right, and these kind of questions are very huge possibility of coming in your JRF physical science, this year maybe, because ऐसा questions आते हैं. I have seen lots. They will just ask like this directly. They will ask name of the institute, कहाँ पे मिलता है, बताओ, कब हुआ था establish, बताओ. According to Bronsted-Lowry concept, what is a base? Proton donor, proton acceptor, electron donor, OH minus donor. What do you think? I cannot see any replies here. There might have been some glitch, probably. All right, so Bronsted-Lowry concept, the base is a proton acceptor. और यहाँ पे जो electron का concept है, when it is electron, it is called Lewis concept. So Lewis concept में, if it is electron donor, it is called a Lewis base. If it is an electron acceptor, it is called a Lewis acid. And Bronsted-Lowry, it is defined on proton. So if it can accept a proton, that is a base. If it is can donate a proton, that is a Bronsted-Lowry acid. All right, moving on. Buffering capacity is highest between the following pH. This question is also extremely easy, and any soil science student knows this definitely. I have total hope कि इसमें कुछ बताना तो बिल्कुल नहीं है. So can anyone tell me the answer? और मुझे comments क्यों नहीं दिख रहा है यार? I cannot see any comments. Probably there might have some problem. So I know all of you know the answer of this, and the answer is 4.5 to 6. The buffering capacity is highest in that, right? Probably there might have some problem. So I know all of you know the answer of this. So moving on to our last question. So we will end our session today with this, which is the heart rate of sugar beet is due to the deficiency of heart rate of sugar beet is due to the deficiency of, I don't know whether you are watching this or not because I cannot see any comments. So I'll directly go to the answer. Oh, yes, of course it is boron. And I have taken this directly from ISSS. Yes, now I can see all of you. क्या हुआ था बीच में यार? Anyhow, so this all are very important. So I have taken the whole screenshot for you, the all deficiency symptoms. इसको अच्छे से पढ़ लेना. Heart rate of sugar beet is a very important disease. All right. इसके पहले जो question था, this one I think all of you know, right? This is 4.5 to 6, right? इसमें तो कुछ बताने का है नहीं. इसमें बिल्कुल भी कुछ बताने का है नहीं. And इसके पहले जो था, I think all of you have seen this also, Lewis acid, Lewis base and Bronsted-Lowry acid and base concept. So, all right, we will end our session today. We extended our time by 10 minutes. That is not a problem. Tomorrow we will complete the rest part of this question, and this question set is very interesting. I'm telling you, this one is good. It has got good questions that might come in the exam. And tomorrow will be the last day of the expected series, and there will be no more question solving. I think it is enough. 1 month, abhi 1 month to study ke liye chahiye. So no more questions. We will directly go to marathon, and that marathon series is going to be extremely interesting. The whole revision you will get, the whole subjects, whole chapters you will get in 2 hours, maybe 3 hours. So those are very important, and please, timing you will get, it will be scheduled on our YouTube channel only, live on our AgriAddict YouTube channel. You will see. The first classes will be handled by Purvita, and then it will be by Rohit, and I will come in the final part. I will be taking the soil chemistry and the soil fertility part. So we will have a nice session there and a very good revision. So tell your friends, whoever is there, you can tell them, and we will have a very nice revision there. And the marathon series is going to be very exciting, and it is going to be very power packed. It will be very helpful for you, even more than question solving now, because now the time is only to revise and only to recall whatever you have read so till now. So do not go into new questions and new concepts now. Whatever you have read, usko recall karna hai, usko yaad karna hai, and usko revise karna hai बार बार, ताकि वहां से कुछ गलत ना हो. Nothing is wrong from there. All right. So we will end this, and thank you so much. So I'll be ending it now. Anyone has anything to say? Or if you like the session, please drop a like. Please tell me in the comments. That will give me some motivation. And again, I will be telling the same thing. I am very new in this domain of online teaching, and if I had made some mistakes, if you did not like or anything, so I apologize for it. Otherwise, I am always available there for you. You can ask in the AgriAddict groups, you can ask in WhatsApp, anywhere you want, and I will be there for you to answer, to solve your doubts. I will give regular questions also. So anyone wants to write anything? Anything? Kuch bhi? Otherwise, I will end the session. All right, Aishwarya, the thumbs up is good. Timing you will know in the due course. You will get to know in the due course. It will be scheduled, and All right. Goodbye, everyone.